Hello again. We're coming at you for another day of coding stuff with Jake. Chemistry related things are what we like to do here. So today we're going to be looking at pulling how you would approach pulling data from ChemCAD, which is a chemical simulation software. We have it right here where I am able to access this through the VPN license at campus, but since I am not on campus right now, we have no license to access ChemCAD. So my professor has provided us with another extracted data file, another sets of extracted data files on his GitHub site. As you can see here, a variety of compounds and their properties are pulled into here. It's the text files that contain them. And we'll start with water again to keep an air of consistency. So this is what the water property file displays as. As you can see, this section, there's a couple different sections that you're going to see here. The first one being a number of single properties, the melting point, boiling point, critical conditions, acentric factor, molecular weight, a number of data points that are constant, so they're single properties. And then if you look down here in the second section, we're given equations where two data points are provided for the equation, the coefficients to calculate said equation, and the equation number. And if we search ChemCAD equation, for vapor pressure, we have equation 101. We'll do equation 101. That's just a free trial for ChemStations, who is the parent company of that ChemCAD software. This user guide, I imagine, will bring us to the right place. 14 instances of 101, and most of them are atmospheric pressure. So as you can see here, this is our expression for, or this is the equation saved as 101 in that ChemCAD program, and using equation 101 and the given coefficients, chronologically A, B, C, D, E, F, and G, we will be able to, did I count wrong? We have A, B, C, D, E, G. So it appears ChemCAD has capacity to hold, for this equation specifically, to hold two more variables than are provided by the equation. At most, this equation will accept 5 variables, but ChemCAD allows for the opportunity to enter 7. So using this equation and the values extracted from this file, we should be able to calculate these physical properties that vary depending on the present conditions. For example, the vapor pressure will vary with temperature. As temperature changes, vapor pressure changes as well. Sorry, my roommate just walked in and I was scared my mic would pick up too much. So we're back, and there's again a third section down here of more property data, coefficients to calculate the property data. And then these are for given equations. The Anton equation is a well-established model of the relationship between vapor pressure and temperature that we discussed in previous videos. If you're unfamiliar with that, we go through and model Anton's equation in Python. And again, we're using Colaboratory for our Python coding. All right. So to begin, we're going to want to, like last time, import requests. And then that will allow us to pull the website that we are interested in into our Python code and extract the values. And here we go again. We're also going to import RE. That is regular expressions, and it's the tool that we'll be using to pull our data from these websites. Similar to what we did before with our XPath function, but this time it'll be regular expressions. Another flavor. We're also going to want to import NumPy. And import Regex NumPy. And again, these are libraries of Python code that are established for running certain mathematic operations and other operations in Python. And this will help us to not have to establish every little intricacy involved in our code. We're able to use these tools established by other people to build on that, and the result ends up being a more concise code that is more easily understood. The computing power to operate the code is significantly less. It's much easier to debug, troubleshoot errors that you find if you're not having to read through an entire section for each operation you try to do. So we're going to be using those, and we're going to try to apply the values we're pulling out of the ChemCAD files. For these equations that are provided, we can pull out the ChemCAD, or the coefficients, and then apply these coefficients that we pulled out through regular expressions to the equations specified by ChemCAD and perform calculations to estimate property values. So that's the end goal of this adventure. And all right, so we're also going to want to import the key, or that's I believe from collections, import the key. Let me check my notes very quickly. Yes, it's from collections, import the key. And again, that is a list, a type of list that will be much easier to use as we add multiple data points to, or multiple sets of extracted data from our website into our Python code before converting it to numbers and applying it to the equations. So we also want to import string as a way to help us, or as a tool to convert our strings to floating point values and to evaluate our strings so that we can use them, we can take them as values, and what we pull from the files can continue to be used, even the words, since if you look in here again, it'll be matched with a word. The melting point corresponds with the value here. So a set of strings corresponding with number values. And we're going to have to decipher which is which using the Python code. All right. So we can start as we did before. All right, well, gotta run it, make sure that there's no spelling errors or other hangups right here. Make sure I am recording. Okay, good. And there were no errors, so we can go ahead and start setting up a way to pull this data. So to begin with, we want to have the option of pulling more than just water. We're going to set it up with water to establish our process and make sure it works, and then we'll be expanding it to other properties and testing the quality of our code. So we want to start here, take the URL, and this is our base URL, what would be our starting point value. We want to always start our evaluations from here so that if we do want to change our components that are being assessed, it's as easy as changing the name of what we're looking for. So we start with a base URL here, and we'll name it base URL equal to, and there we go, that's our base URL entered in there. And then we have, no matter what which component, which compound we're looking at the properties of, so many words you can use, and they're all so great. Once we open one up, you can see we have props.text as the suffix, the ending suffix of our HTML file. So if we say, we can save another variable as suffix and allow that to be equal to props.text and props.text, okay? So next we would add the component that we want to begin with. So our component here, which we can change this variable at any time. We should be able to include more than one variable and pull out multiple properties at once. But to begin with, we are going to start with water. And you can see how this would be strung together in a sense where you have the base URL followed by the component and then the suffix. So if you see here, we have our base URL backslash our component's name followed by props.text, which is our suffix. So if we are to look at a another N-butane, for example, we should see our base URL backslash N-butane and then our suffix. So this should be able to pull the data for whatever compound we decide to look for, as long as ChemCAD has data for that component. I've recently learned through my process design class that ChemCAD does not have properties property entries whatsoever for a fair number of components, and trying to create these entries is proving incredibly difficult with all the information that's required to have one working properly. But I digress. So this is where we'll be pulling all the data from. I just wanted to come back to the water page so that we can be looking at what I'm intending us to look at. So shift enter to make sure there's no errors. Nice, clean, easy, quick, it went ahead. All right, so first we're going to want to pull out the single property values. That'll be easier. It'll be a nice warm-up before going to pull out the coefficient values using regular expressions. So we come back to Collaboratory, and we're going to create a dictionary. A dictionary in Python is a new variable containing a number of other variables. So if we create our dictionary, call it single props, to say all of the single properties should be saved in this dictionary. And then dictionaries, you define them with the curly brackets, shift bracket key, and you would enter all of the contents of the dictionary into this section here in between the curly brackets. So we have molecular weight. I'm going to go through and pull a number of single properties that will be important for calculating the vapor pressure of water or any other compound later on in this video or in a following video. So I will pause the video really quickly so you don't have to sit here and watch me make spelling errors. So here we are back at it again, and I have the critical properties that we are interested in all listed out here with variable names. So this is the value we're looking for from our file here, so molecular weight, and then we're going to save it as a new variable name, capital M, lowercase w. And we go through for all of these single properties. We have this heat of vaporization noted as HVAP NB, and this is to clarify that it's the heat of vaporization at the normal boiling point. So atmospheric condition, boiling point, heat of vaporization is what this variable will be representative of, because there's also an equation provided to calculate the heat of vaporization at changing values of temperature. And a liquid will boil at a temperature different than its normal boiling point if conditions such as pressure are altered. From here, we're going to go to another website. It's called Regex101, where we'll be able to test out our regular expression before pasting it into our code. And I'm going to go ahead and just copy all of this, and then pasted into our test string for the regular expression. So this is, the test string is what we're going to be searching for to find, what we're looking for. So now our regular expression, you begin them with the caret. So that's us telling it we're ready to start. And then a backslash or a forward slash space would indicate we're looking for a space value. As you can see, all of these have a space value right before all of the words are provided, all the letters are provided, the strings. Again, so many great words, but we have a space to open up whatever we're trying to find for these single properties. And then if you look further down, it's consistent with this, starting with a space for the coefficient properties. So we'll have to remember that for when we're doing our coefficient regular expression. So next we're going to be looking for, I'll come up. So after the space, we're looking for words. So to denote words, we have a parenthesis, bracket, /W, // will allow for case-sensitive words. It'll grab the words in a case-sensitive fashion. So instead of just grabbing whatever letters and pulling them, it's going to recognize capital M versus the lowercase rest of it. So that's us saying we're looking for words, and the plus question mark here. So we're looking for these words, and this plus question mark is the quantifier. It tells us, as you can see, that's popping up to show me. I didn't actually need to check my notes. How many words we're looking for before the next command. And the question mark is a lazy quantifier, a lazy limit. So it's saying any number of words until the next command. All right. Close that off with a parenthesis, and now you can see this is, we have that first letter is found. Is that working properly? We'll see in a minute. So I'm gonna add this next, it would be a space again. So okay, and then now it's finding any number of letters up until the next space, and we tell it to do this until it finds a colon, or okay. So until it finds a colon, and then another space. It's only finding that right here. Matches any word character equal to A through Z, 0 through 9. Matches the character. It is case sensitive, and then okay. So if no, we're gonna have to do that. Question mark. We have our quick references down here. So I know that we're right up up until here. And then if I do another okay. So we don't need to add it in a second time. We need to tell it to do this so many times. So do I have these correct? All right. I am not sure why I'm seeing these errors. My notes are saying that this is what I'm supposed to do to extend this regular expression to pull multiple words, because the lazy quantifier is telling it to do this until it reaches a minimum. Do we have quantifiers? And we want I will check through my notes and figure this out and come back to complete this in the next video. See